company. Presently, he's heading also many projects. He is working with fuel cell development for ship application, fuel cell development for stationary application for Chinese company, fuel cell development for French company, even 2 watt, 3 watt powertrain vehicle benchmarking, and he is having battery benchmarking for Audi, Tron, Tesla model S and Y. So there are so many projects. He is the part of the team as well as heading. So I've taken a lot of time. Today I used to give a brief lecture as well as a motivation to you about the electric vehicle, about the batteries concept, so that you will have a great future in this area because it is a huge demand. As an electrical engineer, you will have a basic concept. If you have some skill in electric vehicle, you must be placed in a very good company. So, Ayush, the stage is yours. You can take your time, right?
Thank you so much for such a warm welcome and almost telling everything about me. And thank you all of the fellow students for having me here and taking out time of your precious weekends of your final year. I suppose everybody is on final year here, so must be occupied with some or the other thing. Uh, good to back with the college team again. Of course, like most are mentioning that I am always in touch with him. So we exchange ideas to and fro about multiple things. So yeah, it was a nice journey that we started together in 2015. Of course, I would say 2014, 2015. And since then we are in constant touch. And of course, well, Compressor was also there back then. Good good to be back in tight, not physically, but at least virtually. Great. So, I've been told that you guys are preparing for one of the interviews for which is for the battery company in some Singapore, I think. So, before starting with some technical stuff to give you an overview about that, what electric vehicle is and all, I would like to emphasize more on how I proceeded and how is my experience so far in this industry and what I have done. Maybe you can get something out of it to work upon and then a slight bit of motivation to get into the industry, or if not motivation but direction to get into this industry and then make your career out of it. So first of all, being an electrical engineer before electric vehicles or before the era in India, I would say before 2020 or 2018 or 16, it was not a good field for an automotive to enter the automotive arena in India because it was conventional engine. When I say conventional, that is basically gasoline or petrol and diesel engine, then CNG, and the major development work was done by mechanical guys, or I would say. And the only work for electrical and electronic guys were most on the wiring harness, on these wires, cables for engines, for vehicles, some electronics, body electronics of vehicle, and the control units, of course. But as we already know now, the era is starting for electric vehicles. Already started long back globally, and India also has slowly and steadily kicked off quite nicely. So. I started the club together with Sir, and of course, Sir and Compressor supported us quite a lot. And that time we did not have any means. We were not a club like SAE club or Baha club in the mechanical development team or this mechanical engineering department. This was a club which was for students by the college, means we did not took any financial support from students, it was about learnings. We did not participate in any competition, but rather the intent was to develop the prototypes, gain the knowledge, know-how, hands-on experience, and to bridge the gap between industry and academics, basically, because when we go to the industry, any industry, the world there is slightly different. I would not say like others that it's completely different, but it is slightly different. So you have to get the hands-on experience. I don't know, some of you might have already done some course in electric vehicles or might have seen electric vehicles or some attended some workshops or read some papers, but These are available now. It was not there back then, so we just had to go through the books, find the papers, which were also very limited, and we did it with the know-how that we had. And toward the end, we made it quite nicely, and the know-how was good for everybody because most of the people who were there, they are now, if not in the electric vehicle field, but in their respective domains, are doing very good. And after that, uh, I moved to EVL India, which is a subsidiary of EVL List. There I started in the electrification team, worked on multiple projects, vehicle testing, on the of course electric vehicle testing, benchmarking, testing of the components like motor along with the gearbox. So complete different level of testing what we know when we are studying in college, and then also development of those things, developing concept of batteries for two-wheeler, three-wheeler, and then work leading the team for complete two-wheeler, three-wheeler vehicle development. This is again for one of the big Indian OEMs. Hopefully they will launch the product next year, and then you will see, of course, this is one of a kind. And then I decided to move out of India. Like I mentioned, I had multiple opportunities outside India also. So I was moving actually to Bugatti Rimac, the supercar company, and but EVL List gave me a better option and better role in terms of how I want to operate. So I moved to Austria instead of Croatia, and since last year, almost now 1.5 years, I'm in Austria. Here I work as a project manager and a technical lead, where I have done multiple projects already and already doing it. So like one of the projects which I can name is Pico 2030. Of course, nobody knows about this company because it's a Norway-based company for a ship application, but you can easily search in the Google, and recently they are making use for the fuel cell. The fuel cell, what they are developing, or is what they are going to sell it to the multiple ships. It is being completely developed and designed by EVL, and there I led the EE part of the complete fuel cell. Still, the progress is going on there in terms of testing of that fuel cell, and then of course multiple other fuel cell projects that I've done. So in short, 5.5 years of experience, a lot of projects where I've worked upon, and a lot of things which I've gained. The guidance which I had was from Anmol sir and Kamlesh sir back then, and then the missing thing was that I did not have any godfather or any senior who was working in this automotive industry who can guide us in the electric vehicle field. And of course, I try to do for my fellow juniors whom I can be helpful in their career path. So, good to be back with you guys, and hopefully I can be of some use. And therefore, I will share my screen. I have prepared a small presentation, and we can go through it together. It will take, hopefully, not take much time. And then later on, you can ask questions also with respect to this industry, with respect to the presentation, or any technical questions if you have. And then we can see how we can proceed. Great, so just let me know when my screen is visible. Is that visible? Yes, sir. Good. So, like I've already told you about myself, so I will not go through this again, and also Anmol sir told you about these things. So, agenda for today, more or less it's about knowing what EV is, what are the different types of EVs, what are the powertrain components of EVs, and slightly some information about them, and then we will take up your questions. So first when we talk about EVs, then it all started not directly with the electric vehicles. Means again, if we go back in 1800s, then it all started with electric vehicles, with lead acid batteries in starting, but it did not made into the time But when we say after 2000, then it started with HEVs, where the H stands for hybrid electric vehicle, where we have IC engine, which can be gasoline, means petrol or diesel. Usually it's with diesel, not with petrol, because of the power and torque scenarios. Basically, it's a little bit on more detail, but that's how it is. And then it's basically HEVs are where you have motor, battery pack, and also the engine. Means conventional technology mixed with the new technology, where you gain mileage of the vehicle, you gain long range, your cost of operation becomes less than what it is for the conventional vehicle. This technology was considered to be a good technology and more or less a transitioning technology between HEV and BEV, where BEV stands for battery electric vehicle, where you don't have engine in it, completely removed, and you have battery pack, bigger motor, which directly drives your vehicle, and you have DC-DC converter, inverters for the motor, and then charging is required for charging the battery pack. Various advantages of BEVs like very less maintenance and easy, not so complex technology in terms of powertrain. Is comparatively easy to make, but it's not that much easy as well. But at the moment, the disadvantage is the range anxiety at the moment, where we have limited range of these vehicles and the cost of these vehicles because of the high cost of the battery pack. And then one common problem is infrastructure. Unlike petrol pumps that we have throughout the country, we don't have charging stations. But again, the infrastructure is also growing. So that's why EVs are also growing. So EVs are there, and then we have fuel cell electric vehicles, where instead of an engine, we have a fuel cell which constantly converts hydrogen into electricity and charges the battery, and then there is a motor who's driving the vehicle. In this, their input can be, which depends on different type of fuel cell. Like if it is a PEM fuel cell, then the input would be the hydrogen itself. It will be stored in the tanks, and if it is an SOFC, solid oxide fuel cell, then input can be, or the fuel can be ethanol, methanol, biofuel, which will be used, and then hydrogen will be converted into electricity, which will drive the vehicle forward. It is more or less more suitable for commercial vehicle application, means buses and trucks, which are usually traveling long distance, but not for car, because the space is anyway quite less, and then of course we need to also have a look on the cost to energy aspect of the vehicle. So if we see the basic difference which I told EV, in HEV there you don't have any plug-in charging system. There is an ICE, means this engine, and then we have motor and a small battery pack. Advantages like start-stop technology, that it can start a vehicle immediately. Engine usually takes some time to reach the ideal torque which is required to move the vehicle, but motor does not take that. So that's an advantage with the motor. Can somewhat also operate in pure EV mode, depends on the type of HEV configuration. But again, the problem is that there is no external charging, so your engine is charging the battery through an alternator or through a motor or generator. So that's a big problem there. Then we have advanced version of HEV, which is plug-in hybrids, bigger motor, and then bigger battery pack with external charging as well. So better modes of electric vehicles, like it can drive some pure electric range. Engine can be downsized, like suppose if there is a 50 horsepower engine, it can be downsized to 25 horsepower engine with a 25 horsepower motor. So that's an advantage there. But again, the disadvantage is that cost is quite high, and of course maintenance is also high, because it has ICE and BEV, where we have no ICE, as you can see, no zero emissions. I would say zero local emissions, because there is always a debate that you're generating electricity from a power plant, coal power plant or gas power plant, and there we are creating pollutions. But in terms of local emission, when we say tailpipe emissions, which you get it out of your exhaust, there is zero. So that's why it's green. And then we have pure electric drive, zero torque, or basically high torque towards the starting, gas vehicle. Low noise or no noise at all. That's another advantage. And then that's what you miss out on these silencers in these fake silencers needed as well. Safety point of view, it has to be carefully designed because it contains high voltage. Cars might be low voltage if it is a two-wheeler or three-wheeler. Like in India, there are many. But if it is anything above 60 volt, that is considered as high voltage. 60 volt DC, that is considered as high voltage, and usually all fast cars, pure electric fast cars, like now in India, like Nexon EV, Mahindra XUV EV, or Citroen EV. These every vehicle is almost 400 volt or 300 volt system. So those are high voltage systems, of course, quite very well made, that normally any passenger or driver will not get these systems, and there is safety well up to date, up to mark safety protection like dust protection, or like general questions which pops up like water protection. Any questions? Okay. So generally, like if you have there is a general question or myth that if electric vehicle goes into water, what will happen? So such all protections are already implemented in this vehicle. Again, the role of functional safety, which is again very good domain in an industry, is quite important when we talk about functional safety engineers in the automotive field. Then we talk about powertrain elements. So it's engine which was already there. And before powertrain elements, I would like to tell you about what is powertrain. So powertrain is basically required to drive the vehicle or required for main functionality of the vehicle. So in a conventional vehicle, it's an engine. In a hybrid or electric vehicle, it's an electrical machine. Power electronics like DC-DC converter, or basically your chopper, or your charger, and your inverters for control, and along with the controller, which is controlling the machine. Then of course, high voltage battery pack or low voltage battery pack, which is basically a lithium based battery pack. Then industrially we talk gearbox and motor and inverter assembled together, and we call it as EXL, and it is a compact solution unlike in conventional vehicle where we have, and then we had a big engines again. So it can be used on every aspect: commercial vehicle, fast cars, two-wheelers, three-wheelers, even off-road vehicles like tractor and these earth movers. Everybody, everywhere, these all powertrain elements are used, and are used to make the vehicles. So very simple layman terms, there is a battery which gives DC power to the motor inverter, and more inverter converts DC to AC, and then it is fed to motor, which generates torque, mechanical output from an electrical input. Just the basic electrical thing. Then for an electric vehicle, if you see, then what are the main components? Like battery pack is there, and there is a DC-DC converter for the sensors, electronics, and also for your HMI, and it means the dashboard of what you see in your vehicle, for your headlights, horn, any other sensors. Can be a DC-DC converts with high voltage to low voltage. Basically, in theoretical terms, it is a chopper. And then We have onboard charger where you get means you connect the external charger like this, and it helps in charging the battery pack. So it can be the external charger, can be a DC charger, can be a DC charger. So onboard charger has a multiple functionality. Sometimes it acts as a direct power converter where it converts AC to DC, and sometimes it is just a power transmission device where it transmits DC to DC. Means when I say sometimes, then it's like use case of this onboard charger, but usually the functionality of onboard charger where it is in these vehicles is usually both. Then we have inverter for all the induction machines or synchronous machines which are used. If there is a BLDC machine, then it's an inverter, and then we don't use any other DC machines in the electric vehicle. So we have inverter which converts DC into AC, and also inverter part of inverter is also the control unit of this motor. So that's what it is there in the overall powertrain if you see on the high level. Motor, if you talk about motor, then we use either induction motor or a synchronous motor for mainly all the way. This for the low voltage vehicles like 48 volt vehicle, we cost effective mode. But if you talk about passenger cars, I don't know the other motors. Motor. In developing the motor is going on basically like we have now. These all are radial clutch fluid motors. We call it like the mix of permanent magnets and electromagnetic magnets. So like which basically determines the efficiency and losses at different load points of the motor use case in the vehicle. In a very simple, so the people have seen or not, but this is an efficiency heat map of an ICE engine and an electric motor. So when we talk about the efficiency, then the blue region is the maximum high efficiency region, and there we have maximum of 42 is listed as a loss. Whereas an electric machine, we have very high efficiency up to 95, even 97% now in industry, and we have higher regions of high efficiency. Means you can see even in the worst case ICE. That is why in every aspect, like when it comes to that who's propelling the wheel or who's propelling the gearbox, ICE is far behind than the electric motor in terms of size, in terms of complexities, in terms of performance, everywhere. So that's about motor. And then why we need an inverter? Simply very basic electrical terms. You guys must be already aware about it. We need a sinusoidal wave and three-phase supply for the electric machine, whereas battery delivers a DC constant volt. So we need a device which will convert this three-phase into a DC, constant DC wave into a three-phase wave, and that's why we need an inverter. Apart from inverter, we have the controller in it, and which will also which helps how to operate this motor. And usually the control strategy which is used is for field oriented. Field weakening, field oriented weakening control strategy that we use, and that is quite important at the moment, of most commonly we use an important strategy that we use. In very simple terms, if anybody wants to understand, then higher the current, higher will be the torque, and higher the frequency, switching frequency of the inverter means this pulse frequencies, then higher the speed of the motor. So that's very layman terms if somebody wants to understand. And then basic that okay, what we need to do if we are designing an electric motor, what targets we need to achieve. Then we have an EX, and then there is the controller along with the inverter on top of it, all under one housing connected to each other is a compact solution. Advantage that it has a compact solution, cheaper than overall assembly takes, and also because it's a compact, therefore there is less losses in terms of when the energy is transferred from one part, like from motor to gearbox, and also likewise from inverter, because there are literally no three-phase wires, so there are no transmission losses, not even a bit. It's like directly end-to-end disconnected with the inverter and motor. And gearbox is also quite small, unlike in ICE where we have 5 gears, 6 gears, or if we go to Formula 1 then 8 or 10. Then in electric vehicle we don't have these gears because motor itself is capable of delivering all, all these torques. It is just that we want to amplify, then we have I, the, the single stage motor torque is quite high. Mechanical engineer calculate such high torques and high speed lifting is constantly, because usually you don't go and say that okay it's time to change the gearbox. It is expected that gearbox should work completely or for the complete life of the vehicle. So it's quite good. EXL, EVs, not in two-wheelers, but in some three-wheelers already. And then for four-wheelers or onwards, it is how these are integration, where this inverter is on top, but it's still separated. Then there is a semi-integration where the housing is shared, but inverter is still sitting top. But then the fully integrated is where motor, gearbox, inverter all under one housing means if anything is faulty, you have most cost efficient solution, although assembly and service is very difficult. Then battery, I would say the most important part of the vehicle, because if you don't have the energy, you don't have the fuel, you cannot drive the vehicle. So multiple cells, like you might have already seen these A or AA batteries in your day-to-day life. But these are not A or AA batteries, these are specific EV batteries, cylindrical, prismatic, and can set battery and or pulse basically. And so these are integrated all together in multiple numbers to form a module, and all these modules are integrated together along with the control unit to form a battery. Now, usually in electric vehicle we have lithium-ion batteries, 99.99%. Why lithium? That's a big question. The answer is because of its electrochemical potential. It is the lightest metal, lower in density, means weight, and with respect to that, it has highest energy, or say high energy, not highest, but high energy to weight ratio. Of course, it's earth metal that we extract out of air or water. You have to extract through mining, process it, and then bring it to the battery packs. That is why this is expensive, because initially there were not so many lithium mines. The technology for taking out these lithiums and then making it, but now throughout the world as the lithium mines are being investigated or being geographically figured out, the cost of these lithiums are decreasing over a period of time now. Then if we see with respect to the different battery packs, like it's not like that engineers did not investigated other battery packs. Lead acid, which was still most used as a 24 volt or 48 volt or 12 volt battery in most of the passenger cars and two-wheelers. It has lowest of all these energy to weight ratio, 30 watt hour per kg. And if you want to use this battery in a car to have to drive 6 times the weight of this car itself, it cannot be packaged, it cannot be integrated. Likewise, nickel metal hydride and then lithium ion and the ongoing advancements means different types of lithium ion battery, and then of course new batteries like sodium ion or nano batteries, which are basically where we are working on anode. For the nanotechnologies, there we are expecting that it will go up to 1500 watt hour per kg. So as soon as the technology is developed, the size of the battery pack will be reduced, higher will be the energy, the cost will also be reduced as soon as the commercialization is there. It is more or less that it is this particular component means battery in general, irrespective of vehicle type. There is a lot of things which we need to do, because unlike an ICE engine where it is like, okay, we have achieved something, now we cannot go beyond this, or like motor that okay, 97% efficiency is achieved. Something we can do here and there, but not a lot of things. But in battery pack, 5 years down the line, there would be at least 10 steps ahead than what we have now. Because when Tesla started in 2008, it was quite basic battery what they made with their first vehicle and the Roadster model. And that too, it was quite good. But now what the category of battery packs in the vehicle, whether it's Tesla, Audi, Mercedes, even in Indian vehicles or Chinese vehicles like BYD or anything, they have quite good quality battery packs in terms of technology, in terms of technical specifications, and it will be more better in the near future. So, in terms of cells, like I told you, cylindrical prismatic pouch, all these cells have their own advantages and disadvantages. Most commonly used is cylindrical and two-wheeler battery pack cell. So, but highest performance, and this is most safe cell, but out of 3 lowest performance, and this is a moderate one. So it depends upon what type of goal of vehicle is, means we want high performance vehicle, safety or moderate safety or lower safety. These cells are used, and also considering the cost aspect as well. This one is the cheapest one, this one is then slightly expensive than this, and this one is the most expensive cell. Of course, in cylindrical we have different sizes now. It started with 186500, where 18 was the diameter and 65 was the length. 0 starts for the notation that it is cylindrical. Then it moved to 2150, when it is A4685. 46 is the diameter in mm, and 85 is the length of the cell. But it's all about how you package the cell, the higher the energy density will be there. Then, what is the battery pack? So, battery cells with integrated cells together with some electronics which monitors all these cells. We call it battery module. Module all together combined with a main control unit with some cooling arrangement if it is required in bigger packs. If it is required, we create a battery pack. It may be or may not be, can be used in multiple two-wheelers, like I developed, means ADL developed two-wheeler, three-wheeler modular solution that we can use same battery pack in two-wheelers and same in three-wheelers, and usually a swappable of nature. But when we see a battery pack like we have it now in the picture, this is specific to one model, to the vehicle space that it has, and it can be used in a modular form in another vehicle also. Then this brings to the last slide some example just to show you guys and about the good feeling. So Tesla Model X, It has some floor-based T-Series integrated battery and two motor and axles on both the rear and front axle. Basically it's a four-wheel drive, front and rear wheel drive vehicle. Quite a good vehicle. We also benchmarked this battery. I was also involved there, so yeah, I know about this battery quite nicely. And then we have Hobby e-tron. Of course, we have different models of our Hobby. You can see the battery pack of Hobby is different than the battery pack of Tesla. And then, of course, this here we have the cylindrical cells in Tesla Model X, and in Hobby e-tron we have the pouch cells there. So this was a brief overview about the EVs and how you see the EVs. And let's bring last slide.